With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem states a sonometer wire under tension of 64 Newton vibrating in its fundamental mode is in resonance with the vibrating tuning fork. Now the vibrating portion of the sonometer wire has a length 10 centimeter and mass of 1 gram. Now the vibrating tuning fork is now moved away from the vibrating wire with constant speed, and the observer standing near the sonometer hears 1 beat per second. What we have to calculate? We have to calculate the speed with which the tuning fork is moved if speed of sound in air is 300 meter per second. So let us draw the diagram for better illustration. So you can see I have drawn a sonometer wire, and suppose that it is vibrating in its fundamental mode. So there will be like this. So this will be vibrating. It has tension 64 Newton. It has length 10 centimeter, mass 1 gram. So let us now try to find out the frequency with which this sonometer wire is vibrating. So what is the formula to find out frequency? This is simply 1 divided by 2L under root T is the tension in this string, divided by mu, where mu is the mass per unit length. Here mu is simply equals to M divided by L. Now if we put all the values, what we are going to get? We are going to get 1 upon 2 into, this is 10 centimeters, so 10 to the power minus 2. Tension is simply 64 Newton, and if we find out mu, so this will be simply 10 to the power minus 2. We can put the mass here, 10 to the power minus 3 divided by 10 into 10 to the power minus 2. So this will be 10 to the power minus 2, and from here what we get? We get frequency of sonometer wire as 400 Hertz. So you can see that the initially tuning fork and this are in resonance. So both have frequency 400 Hertz, right? So both have frequency 400 Hertz. So if an observer is situated here, it will not hear any beats since both have same frequency. Simply it will hear a loud sound because they will be in resonance. Now what actually happens is that if this tuning fork is moved away with say some speed v, then this observer hears 1 beat per second. That is, there is a difference in frequency between this tuning fork and this sonometer wire. So in that case, what will be the frequency? Let us say N2 dash of the tuning fork. It will be simply 400 minus 1, since the observer here 1 beat per second. So the frequency of this wire will not change. It will be 400, and since this is moving away, tuning fork is moving away from the wire, so if he has 1 beat per second, so the frequency will be simply 400 minus 1, so which is simply 399 Hertz. So this is the apparent frequency heard by the observer. Now if we apply the formula, we know that the speed of sound is traveling in this direction to the observer. So this is the direction of speed of sound, and tuning fork must be traveling in the opposite direction. So if we apply Doppler effect, so this will be simply equals to N2 dash will be simply equals to N2 V naught minus, observer is stationary, divided by V naught plus Vs. Why? Because they are both are opposite, so that will get added. Now let us try to put the values. N2 dash is simply equals to, N2 dash here is simply equals to 399. So this will be equals to 399. N2 is 400 and speed of sound is 300 divided by 300 plus Vs. So if we solve from here, what we get? We get Vs equals 0.75 meter per second. So this will be the final answer. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.